All right, good morning. We'll be treating probability today, and we'll be talking about a lot of things about it. It's just more or less like an introduction. Now, probability is basically talking about the possibility and impossibility of an event to happen, right? So it's basically talking about possibility. Like, are we going to say that okay, let's say the weather change now, probability comes in and asks the question, is rain going to fall, is rain not going to fall? So let's go straight. Now this is a man holding a coin. He's a man, actually. If you see his hand is kind of hairy, so we'll call him a man. Any woman that's hairy. um Wonderful. So um the the man is holding that coin, and you notice that the coin is in the air, so that means he flipped it. So when he flips it, there are two possibilities, because there are two sides to that coin: the head and the tail, the top and the bottom. So whenever the coin comes to his hand, there are two possibilities that we have there. That is the fact that he must either get a head or a tail. It's impossible for him not to get anything, right? He must either get a head or a what, or a tail. So that leads us to what probability. So I said here that probability means possibility. It's a branch of mathematics that deals with the occurrence of a random event. Now, the word random means that something is not steady, right? It happens in different ways. So when you say an event is random, it's like it's not steady, it's not definite, it's not a given event, it's not something that will happen immediately. It's something that it can happen this way today and happen this way tomorrow. So that's just what it is. And the formula for probability is given by number of favorable or required outcomes to the total or possible outcomes, right? So required is what you're always asked to do. Total is always given in whatever question you are asked to do. So today we'll just be talking about just laying emphasis, building a foundation, right? Then from next class, we'll take time and go into it properly. Now, some materials that you might use for probability, to better explain probability, you can make use of Ludo, you can make use of dice, you can make use of coins, you can make use of cards, and many other stuff. So those are materials that you can use to actually give you a better understanding of what probability is. So we said once again that the probability formula is given by favorable outcome over total outcome. Favorable outcome over total outcome. In some textbooks, you will find required outcomes. In some textbooks, you will find possible outcomes. But do know that whenever they are saying possible, they are still saying total. Whenever they are saying favorable, they are still saying what do you call it? They are still saying required as well. So, a quick question. Now, they say there are 6 pillows in a bed, 3 are red, 2 are yellow, and 1 is blue. What is the probability of picking a yellow pillow? Now, straight. Now, what in this question, what is our possible outcome or our total outcome? Our possible outcome is 6. Why? Because it's the same thing as talking about total. So there are 6 pillows. So the total number of pillows there is 6. Now that said, what's the probability of picking a yellow pillow? Now, what is the required outcome? The required outcomes there is 3. Is 2, because 2, we have 2 pillows there. So you are going to have 2 over 6. 2 as our required, 6 as our possible. 2 over 6, which is equal to 1 over 3. So this is another question. I'll still send this material I'll still send this material for better understanding. So this question says that um there is a container full of colored bottles. There's a container full of colored bottles. There's a container full of colored bottles, and okay, there is a container full of colored bottles, red, blue, and there's a container full of colored bottles. So you have a container full of colored bottles. You have red, blue, green, and orange, red, blue, green, and orange. So some of the bottles are picked out and displaced. Now, the word displaced means that they were not brought back, they were not returned back, they were displaced. So Summit did this 1,000 times, right? This displacing it did it 1,000 times and got this result. The number of blue bottles picked out were 300, number of red bottles picked out were 200, number of green bottles picked out 450, and number of orange bottles picked out was 50. So now the question is now, what is the probability that Summit picked a green bottle? And they now said if there are, I think there's supposed to be 1,000 bottles in the container, how many of them are likely to be green? That is supposed to be 1,000, not 100. What is the probability that Summit will pick a green bottle? What is the probability? So I'll give you a few minutes to try that on your own. Try that on your own based on the formula we talked about, the required outcome and the possible outcome. Remember that the possible outcome is the total number. So our total number here, giving you a hint, is 1,000. Now the question is that what's the probability that Summit picked a green bottle? I'll give you like 10 seconds to give it a try. All right, so let's move straight to the answer. Now they said for every 1,000 bottles picked, 450 are green. So to get the number, to the question says what is the probability that Summit picked a green bottle? So it's going to be 450 over 1,000, which is 0.5. They now said the experiment. Okay, the next question says that if there are 100 bottles, sorry, this is supposed to be okay. If there are 100 bottles in the container, how many are likely to be green? So please, I'm sorry. Yes, we are correct. Now the experiment implies that 450 out of 1,000 bottles are green. So if there are 100 bottles, 45 are green. It's just simple math. See the same thing as 45, 450 over 1,000. 0 will cut 0 and you have 45 over 100. So if 100, there are 100 bottles, 45 are certainly green. Now let's move forward. That was just a simple example. Types of probability. Now there are basically three types. There are more types, right? But there are basically three types, which is theoretical probability, experimental probability, conditional probability. So we'll try and define these terms and a few other terms. And the next class we would work on. We'll start with either experimental probability or theoretical probability and try to treat questions there to give us a better understanding. So straight, theoretical probability, it is based on the possibility chances of something to happen. Now, the theoretical probability is mainly based on the reasoning behind probability. Thank you. For example, if a coin is tossed, the theoretical probability of getting a head will be 1 over 2. Now, let me explain that. A coin has two things, a head and a tail. A coin has two things, a head and a tail. So if you flip it up, there's always one possibility. Either you get a head or you get a tail. So that means if you are going to get a head, that is your required outcome for getting a head will be 1 over the possible outcome, which is total outcome 2. That is 1 over 2. Now, if you are going to get a tail, it's still the same thing as 1 over 2. Because that is just one possibility. So we will go deeper into this our next class. So experimental probability. Now it says here that it can be okay, it is based on the basis of the observation of an experiment. The experimental probability can be calculated based on the number of possibility outcomes by total number of trials. For example, if a coin is tossed 10 times and heads is recorded 6 times, then the experimental probability is 6 over 10 or 3 over 5. Now, what does that mean? We'll still solve examples on this, so please don't get confused. Just understand what I'm trying to say. Now, theoretical probability doesn't deal with much, but experimental is based on different things that are done, right? Different things that are done. The example we cited there was that a coin was tossed 10 times. It was tossed 10 times. And it recorded 6 heads. 6 heads. So Now, if we are asked what's the probability of getting heads, that will be 6/10. Why? Because we recorded heads 6 times. Now, if you're now asked what's the probability of not getting heads, we'll still get to all those things. Don't worry, we'll still get to all those things. Now, conditional probability. Conditional probability is the likelihood of an event or outcome occurring based on occurrence of a previous event. Let's say, for instance, last night somebody was very, very sick. Now, on a normal human being is supposed to eat in the morning, at least, if not from 8, 9, 10, 11, and so on and so forth. That's for a normal human being. Now, if such a person was vomiting seriously the night before that day, now because of that occurrence, the possibility of that person eating that morning, it's not very, very strong. So that's just an example of conditional. So we want to quickly consider some terms in probability. We want to quickly consider some terms in probability. The first one is sample space. Now, sample space is what? Is the set of all the possibility outcomes to occur in any trial. The set of all the possibility outcomes to occur in any trial. Now, let me quickly say something. Now, in probability, we'll talk about all these things. Now, we'll be dealing with materials, right? We may be dealing with dice. We may be dealing with cards. We may be dealing with many other stuffs, many stuffs while talking about it. So now, an example there, you have tossing a coin. Now, the sample space S is actually 2, head and tail. Now, what does that? That's what we are trying to say here. Sample space is the number of all the possibilities that can happen. So, if for instance, for a coin, if I flip it up, what I must have is either a head or tail. So, the two things I have is head and tail. If I'm talking about a die, like a die now, when I'm combining what do you call it? When I'm combining when I'm playing Ludo, so instead of using 2 dice, I used 1 die. So the possibility I must have is 1, 2, 3, 4, 5, or 6. I must have one of them. I must have one out of those numbers. There's no gainsaying. There's no thing that can change it. Is either I have 1 or 2 or 3 or 4 or 5 or 6. So the sample space for a coin, just one coin, is 2, while the sample space for a die is 6. Now, when you talk of cards, they say 4 of hearts is a sample space point. Then the queen of clubs is also sorry. Now, the next thing is sample point. This is one of the possibility result. This is one of the possibilities. So a sample space is the total of all, but individual you call it sample point. Now, experiment or trial. This is this is a series of actions where the outcomes are always uncertain. An experiment, we all know as scientists, every experiment we do, there is always no certainty that this is what will happen. It is when it eventually happens that we can say for sure that this is what has happened. So we also talk about an event is a single outcome of an experiment. So when you perform an experiment, what eventually happens is an event. I just said it, eventually. So what finally happens is actually an event. So a series of actions where the outcomes are always uncertain. So example is tossing of a coin, selecting a card from a deck of cards. So that is just what we're trying to say. Throwing of dice is also there. Now you also have an event. Now an event is a single outcome of an experiment. Sorry, that was what I was trying to say. Getting a heads while tossing a card is an event. Now when you toss that card, you are expecting something. So what eventually at the end happens is what your event is. Now outcome, possible result of a trial or experiment. You have complementary event. Complement of an event is the event not happening. Is the event not happen. For instance, if I pick my phone and I want to dial a number. Now the complement of what I'm about to do is that I don't dial a number. So complement is trying to tell you something that is not going to happen. If NEPA or the distribution company, they turn up their power and houses get light. Now the complement of that event is they're not turning up the power they not distributing light, electricity to all the houses. So you also have a possible event, and those are events that can not happen, that cannot happen. Now, I said here that probability, right, can basically be expressed as R over N. Now, that R means the R is your required outcome and N is your total outcomes. Now, the probability that an event will not happen will now be 1 minus R over N. Let me explain that. If the probability that you are going to be an engineer is 1 over 2, the probability of you not being an engineer is 1 minus 1 over 2. We will still get to all these things when we start solving examples. 1 minus 1 over 2. That is the probability of you not being an engineer. So, in actual sense, the total probability will now be one probability that something will happen plus probability that something will not happen. This E complement you see here, this complement you see here, it means that that event will not occur. So the real probability totally must either give you 1 or 0, because if you look at what we have here, they said now we can say P, that's possibility of an event plus possibility of an event not happening, is equals to 1. So you understand? So if I say the probability of me going to church is 1 over 5, probability of me not going to church is 1 minus 1 over 5. So if you actually had the 1 plus 5 over 1.5, if you had 1.5 plus 1.5, if you add half plus half, it will still give you 1. And if you have half minus half, it will give you 0. So most times probability must end up having 1 or what? 0. That's just what we are trying to say, because addition of everything will still give you 1. So that's just it. So that's just the idea. Now we want to talk about some kinds of events, want to quickly talk about some kinds of events. Want to quickly talk about some kinds of events. This is a class assessment, but we'll deal with it at the end of class. Now we want to talk about equally likely events. Now, some textbooks will call it equiprobable events. Now, these are events that their chances of occurring, they are the same thing, right? Their chances of occurring are the same thing. Now, example is that if you throw a die and the probability of getting 1, when you throw one die, your sample space is actually 6. So the probability of getting 1 is 1 over 6. Also, the probability of getting 2, probability of getting 3, probability of getting 4, probability of getting 5 and 6 is still the same 1 over 6. So we can say that, hence, the following are some of the examples of equally likely events when throwing a die. So 3 and 5. 3, the probability of throwing 3 and 5 is the same thing. Getting an even number and getting an odd number on a die is still the same thing. It's still 1 over 6. A even number, one even number. So getting 1, 2, or 3 on a rolling die are equally likely events, since the possibility of each of them occurring are the same. So just know that equally likely events, some textbooks will call them equiprobable events. They are events that their possibilities of happening, their chances of happening are the same thing. They are the same thing. So the next one we have there is complementary events. The next one we have there, please, I'm trying to see what this is. Complementary events. The next one we have there is complementary events. So complementary events, okay, I'm going to cite an example because I've sent the material. Like a person, okay, complementary event, I talked about it when I was trying to give this diagram. So complementary events are actually those events that they kind of, when one event is happening, the complement of it will become that event not happening. Do we understand? To become that event not happening. So saying it will rain today, the complement of it raining today is not raining. So examples you have, it will rain today, it will not rain today. The student will pass or not pass the exam. You will win the lottery or you will not. So that is just the idea of it. Now the next one is mutually exclusive events. Mutually exclusive events. Now, these are mutually exclusive events that there are two events that cannot occur at the same time. There are two events that cannot occur at the same times or simultaneously. So the probability of those two events occurring is zero, and the probability of those two events not occurring is zero. So the way it works is that it's either one will occur and the other will not occur, and one will not occur and the other will occur. So that's just the idea behind it. No, you also have dependent and independent events. So summarily, for that, if two events are mutually exclusive, we said what mutually exclusive is just now, two events that cannot happen at the same time. So if two events are mutually exclusive, they are not independent. And also independent events cannot be mutually exclusive. So we can say two events are dependent if one event changes the probability of another event. You understand? That's one. When one happens, it changes it affects the other event happening. So when one event is affecting another event, for instance, let's say there's a lockdown in a particular country and people are supposed to go out that day. So if the lockdown comes up, people cannot go out. So those are two events that affects another. That's what um dependent events are. So the next thing I want to talk about is probability tree. Now, this probability tree is a very, very interesting topic. It's a topic that shows us um, occurrences, right? Because if you see here, somebody doing an act. Now, this is somebody tossing a coin. So when the person tosses that coin, it gets two outcomes. Now, this is the first trial, head and tail. Now, if it goes further to toss it again, there's always possibilities. We'll get to all these things. So I just wanted to just give us like a what do you call it, a a brief understanding of this what we've been talking about today. So that's just it. So we talked about a lot of things today. So I just want you to quickly try these exercises on your own. The class assessment is give an example using real life experience to explain probability and events and outcome, independent and non-independent event. I want you to use real life experiences and explain it, and also mutually exclusive events. So if you have any question, please drop your question in the comments, and by the next video I will answer the question. But by the next class we will be dealing with each of these probabilities individually. Thank you very, very much.